Hey everybody, BTO Pro here. Today we're going to talk about killing Polymer. Just stabify it to death, okay? So, all right, it's hyperbole because that gets the clicks and somehow you ended up here. So, what we're talking about today is I am going through and systematically removing references to things like paper button, paper icon button, iron icon, iron-ajax, anything that's in the Polymer universe. And the reason for this is not because I hate Polymer. It's because LitElement is so much smaller and faster. And so we've been moving to LitElement off of Polymer element using this progressive decoupling, collapsing type of methodology over the course of the last year. Working in higher education, when you ship someone an application that loads in 400 milliseconds, maybe that's terrible out in industry land, but we have applications that take 10 minutes to load. Not us personally, things we've paid into, and I'm not kidding. So we are switching off of Polymer. We've gotten off of the Polymer element base class, and now we're getting into the shadow roots of all of our elements, and we're removing references to things like iron-ajax, etc. So this is going to be a series of little videos and posts about ways we were able to do that. But the first one I'm going to show is a combination of getting off iron-ajax, but using an interesting technique with mutation observers, intersection observers, in order to only load data once it is visible to the user. So if you want to learn more about our projects and our mission, you can go to hackstheweb.org, hear all about it. It's all made out of web components. If you want to see the code and pick through it prior to NPM, if you go to github.com/elmsln, that has all of our repos, or /LRN web components is our crazy large mono repo of elements here. And you see we've got just a couple, and each of those has lots of elements inside of it as well. Anywho, so if you get LRN web components wikipedia-query, I'll show in a second here, it has prior dependencies, and even a year ago wouldn't have been LitElement, would have been Polymer element. But so it has citation element, which is something we use for citing material, and that at Polymer iron-ajax tag that I was dependent on for so long. So let's see how we get rid of that. So I've got I'm in my mono repo, I'm in wikipedia-query, and I'm going to fire that up. So any of our elements, you're able to just run yarn start, and it fires up this little Polymer demo place. So we still use the Polymer demo thing for going through our elements. So let's refresh on that. Okay, and now let's pull up VS Code. So in VS Code land here, I have pulled up currently the intersection observer and Wikipedia query. So let's look at what the IntersectionObserverMixin does first. So if you want to use this, we wrote a vanilla JavaScript, but it has some nicer integrations with LitElement. But it is vanilla. So it's an IntersectionObserverMixin. And so what you can do is basically boil your integrations with intersection observers down to a single call within your element. So that you know whether it's visible. So quickly reading through what this does. It sets up a superclass, which allows us to mix it into other things so that we can use it in this way. So we can import it, and then we can make a new class that extends something else and mix this functionality into this class, right? So it kind of mashes these two classes together if you're not familiar with this syntax. So looking at the superclass, we can see we set up whether or not the element is visible and some thresholds associated with when you see it, how often to poll for it, things like that. I mentioned it has some first-party LitElement integration, and so that would be seen in the static get properties. So it's automatically going to pull in a Boolean-typed variable of element visible, and it's going to reflect it. So you can use this as to whether or not to show or hide things at a CSS level. Then in our connected callback, we set an intersection observer. And so the intersection observer saying, okay, if we're not visible currently, make an intersection observer, which means that this is visible. Now you can tweak the thresholds. I just have a pretty generic, like, hey, once it's 25% visible, it's considered visible. so that as you're scrolling down the page, it would come up into the viewport and you go, oh, okay, there it is. And then you run your code. So imagine we have that, right? We have this intersection that's doing the observation, and it's going to call this handle intersection callback when it's done. So then on disconnect, we get rid of it, right? So if this element comes off the DOM, kill off that intersection observer. I'm not entirely sure you even need that, but I just like to do it for cleanup. So then we have handle intersection observer callback. So this is an interesting one. So we say, okay, there's been an intersection generated. Let's verify it's across our visible limit, which would be 25% as the default. If we hit that threshold, set us to visible. Then when we have this as an initial flag, so this is the default behavior, drop the intersection observer once we are visible. So it's a fun aspect to this. Your element is going to come into view and trigger, not an event, but trigger an attribute, property change, what have you, to say, hey, I'm visible. And then by default, this is going to go, okay, now we don't care about this anymore. So it's very performant. You're only listening for these in the time, and you can disable that, right? Or just write your own if you know how to do that. But so that's what this mixin does. It can apply this to any element. So how do you end up using it? So I'll give two examples, but the first is in wikipedia-query. So previously in wikipedia-query, what was happening is, I mentioned there's iron-ajax involved, is it's making an Ajax call to the Wikipedia API and then returning the article in question. So in this case, you see there's no search term. I have that just to make sure it doesn't, brick. And then we have, okay, there's the Polymer search term. And then in this next one, we have Drupal. And it says, oh, okay, so search Wikipedia for Drupal. Here's what the article snippet is, right? It has it in context. And this isn't an iframe. It's actually just pulled the text directly off the API, put it in context, and made it look like it's in an iframe. So, and presented the result. So let's see how that actually ends up working. So we mix in the intersection observer, have some very basic CSS, and then we render only if it's visible, right? Because now we have this variable that's going to update automatically when the element is visible. And I'll mess with the demo page so you can actually see this happen. So when it's visible, we do this in the render engine, right? So immediately we've got this performance savings as far as this is not sitting in the DOM. LitElement is not going to paint my citation element or anything else until it's actually visible to the user. So if it's way down the page, yes, you've loaded the initial definition of Wikipedia query, but it's not taking up any screen real estate at the moment because there's no reason for it to. So then we have an update article call. And this is how I was able to effectively replace iron-ajax. So iron-ajax is just it's a nice tag. It sits in the page, and you can just say like, hey, whenever these parameters update, it basically reruns the call. It's cool. It's no longer needed. So we're slowly getting rid of it. There are some nice event handling that it did that we leveraged in a couple places. So I have update article, which fetches against the Wikipedia API and inputs the search term. It says, give me it as JSON, gets the response as JSON, if it's an okay response, and then runs handle response. So handle response is just going to parse through just a double check that there's no JavaScript injection, anything like that. And then it's going to forcibly set that HTML into the page, right? So a very quick scrub of styles, things like that. Wikipedia is not sending those, but just to be safe. And then after that, we just throw it in the page. And that's what you end up seeing. So fun thing with this fetch, I said, okay, well, as I'm converting this off of iron-ajax, and previously it would just be like, I exist in the DOM, even if I'm way down the page, and go query Wikipedia. So your Wikipedia thing could be like 6 page scrolls past where you are currently, and it'd still be hitting Wikipedia. That could be, messing with timing. That's data that it has to go fetch. So what if we leverage the intersection observer aspect to say only query that data when we're visible to bother to present the material in the first place? So we've got the template not rendering unless the element is visible, right? So this is LitElement saying, hey, this is a conditionally render this, otherwise render nothing. Then in our updated lifecycle, which is a LitElement aspect, what we do is say, okay, if we get a change record for element visible and it's true, which is what this is a goofy, I always write them this way, but it's a goofy way of saying it's this dot element visible. If element visible has changed and it is now true, dynamically import the reference to citation element. So we're not even loading citation element. If that Wikipedia tag is way down the page, we're not loading the main thing that's rendered, that other web component, unless we visually come into scrolling and see it and go, oh, and here's the definition. So it's a fun way you can use dynamic imports in this way. The next thing it does is it says, okay, if element is visible and we have a search term, then we set a very minor debounce just to make sure there's no flooding associated with like search term changing rapidly or something. And then we say, okay, update the article. So when we have a search term and this element is visible, it's going to run update article, which does the fetch and handles the response data, which then populates this area. That's how we end up getting what's there. So let's see this in practice. So I've inspected here, and I'm going to blow up, make it real big so that we can actually witness this happening. Okay, so the page is loaded, and I'm going to right click here, so we're in that container, right? And we see we have element visible. Oh, element visible is getting set rapidly on all of them. I might have to make this even bigger so it's out of the viewport. Or it could be that that's causing the issue, but we'll see. Sometimes with this iron component page thing, I end up having to, for these types of demos, I need to tweak how it's handled. See, it is still coming up element visible. Okay, so I'm going to have to move it down the page, which is fine. So, all right, let's go into my demo. Okay. And by move it down the page, I mean I'm literally just going to put a bunch of divs as content here, like that. And then I'm just going to, I'll say, keep scrolling to see the Wikipedia query content here. Okay, so we've got that. Hopefully that helps. Okay, good, it did. All right, so what we can see is Wikipedia query. There's 3 of them down there. They have no guts, and currently there's no content in any of them. Okay. Now, as I scroll, that one crossed the threshold, hydrated itself, and went, "Hey, I'm here." IntersectionObserver gets kicked out, so now we don't have the performance implication of that, right? It's no longer monitoring this. It's just that one time, and it went and dynamically imported citation element. Now, I should probably also put in a flag that says if there's a search term, because this is a blank tag just for fun. But let's look at the next one, right? These also became visible because they were flat, right? So that could actually be a reason to not do the conditional rendering because it's so tiny in this instance. But to illustrate that it is actually not tripping all of them, right? I'll space these out so they're hydrated independently. Right, so we will inspect. Okay, scroll down. There's that element visible. This one is coming up. Right, and so it happens so quickly that you as the user panning down wouldn't notice this is occurring. However, if we look at the timing of things from like our XHR standpoint, scroll, no message generated because it's not supposed to for that one. This one though, there's that hit to get the file. There's also way later in the page load, if we look at the waterfall here, right? This call for citation element. So we're not delaying the page loading based on citation element's existence, but we're also not delaying the page loading in any way or the user having a slow experience as a result of needing to query and present Wikipedia content in context. So that as I scroll down, oh, citation element goes and gets it, gets those 3 dependencies, right? There was schema behaviors, there's license element, there's this utility thing that we have. So, and again, this is uncompressed here. Well, no, yeah, it's uncompressed utilities and things. But as you can see, citation element, schema, license, right? That's an additional 14K right there that didn't have to download to get that page to just go initially, right? Similar with the XHRs, right? So the XHR here in this case is going to show us our fetch, so that when we get to that, right, that fetch was 17K. I don't want 17K to block the page loading, right? Let alone if I had multiple Wikipedia queries, right? So that one's 9, right? So as I would keep scrolling down, it's going to keep triggering this, and I'm going to get that on demand. So if you want to use just the IntersectionObserverMixin, it's located in the IntersectionElement project off of npm.js. If you want to see Wikipedia query, I haven't republished this new version. The code is up in master. We use Lerna for publishing, so I want to make sure that everything is cleaned up and rid of Polymer where we see fit, and do a lot more testing before I do a next big publish, because it's not going to jump to 2.7.10. It's going to be like a 2.8. It's a pretty significant change across our entire ecosystem. If you want to learn more about the project, check out hackstheweb.org, or if you want to get into our Slack channel where we have conversations about these things, answer questions, you can go to bit.ly/HAXSLACK. That's Hack Slack. Catch you later, internets.